Okay, so in the last discussion, just we have stopped after completion of the drift and diffusion currents. These are the major two types of currents it allows to flow through the semiconductor materials. One is drift current and the one is diffusion current. Diffusion current in presence of applying an external voltage we have diffusion current without having any external supply due to drifting of charge carriers from one region to another region. It allows to flow some current through this semiconductor materials that we call as drift current. These are the two types of currents we have in semiconductor materials. Now let us see actually P and N. What's the definition of P and N junction, and what's the name for this P N junction? Because P and N are two semiconductor different types of materials. Okay, if I have given two electrodes for these two N and P type of semiconductors, that we are named as actually P and N type of semiconductor. In terms of regions means we are representing like the semiconductor regions of P and N, and this is one electrode, this is another electrode. The name of this electrode will be called as anode, and the name of this electrode will be called as cathode. This might be come across already in the inter level. So anode and cathode. What's the symbol of this particular diode means? This is the symbol of diode. Okay, so this is the anode and this one is the cathode. Either K or C in general we can represent the cathode. Anode and cathode. This is a P and N junction. What's the definition of this P N junction diode? Two-terminal semiconductor device, we name it as P-N junction diode. Two-terminal semiconductor device is a diode. It's a two-terminal semiconductor device. Okay, so what are the different types of semiconductors means? Already intrinsic and extrinsic semiconductors are over. Then, in this particular semiconductors, already in the periodic table we have semiconductors which would have in its valence band the 4 electrons. Those are silicon, germanium, arsenic. So these are the semiconductor materials we have. Okay, gallium arsenide, like gallium arsenide. These are the different semiconductor materials. So the semiconductor materials have in its valence band the 4 electrons. Either silicon, germanium, arsenic, gallium arsenide. These are all semiconductor materials. In this, silicon we are preferring more as compared to any other types of semiconductor materials. But in the second year level, while entering into the semiconductor devices or electronic devices and circuit subject, first you should concentrate on these two types of semiconductor materials. Later on, you will go for different types of semiconductor materials once you step into the VLSI design subject. In the third year, we may be having VLSI, or in the some regulations or some universities in the fourth year also having VLSI design. There we will see the different types of semiconductor materials and its fabrication and uses of these semiconductor materials and importance of this arsenic and gallium arsenide semiconductor materials. Gallium arsenide semiconductor materials in VLSI design. Let us see first is silicon and germanium. Out of these two types of semiconductor materials, which material more frequently we can use and which material less frequently we can use? Let us have some discussion on this particular two types of semiconductors. Silicon semiconductor and germanium semiconductor. The basic difference between these two types of semiconductor materials is the number of charge carriers. The number of charge carriers presence in cubic size of materials. Like the cubic size of the material means, suppose let us see, it's a semiconductor material and it's having some structure. Because of this is a semiconductor material. In each unit of it's a cubic size of unit, like this if you observe, okay, this is we'll consider as a three-dimensional. In its a cubic size, the number of charge carriers present in silicon material is lesser than germanium semiconductor material. That is, number of charge carriers present in this cubic size of material of silicon is a lesser compared to number of charge carriers present in germanium. Either it may be electrons or volts, whatever it is, the number of charge carriers. Okay. So the number of charge carriers present in the silicon is a lesser compared to the number of charge carriers present in the germanium. Because of this difference, the germanium materials we may not use as compared to the silicon. You may be having some doubt here. Why actually number of charge carriers presents in a silicon, even though it's a larger, why can't we actually prefer in electronics? Definitely, it's a right doubt. But the thing is, when there is a possibility to control you people, if you think of it, whenever you have a zeal to learn something from the teacher, then definitely we should have better controlling on you people. Suppose if you haven't any zeal, you are just for the time pass if you are coming for the college. Okay, you are not at all concentrating whatever the teacher covering in the class. Can we have such control over that group of students? Definitely it's less. But still, we are trying our level best to control all kinds of different mentalities of students in the class and absorbing, their concentration should be towards us. In such a way, just we can try our level best to attract the students through our lecture only. The same way here, whenever see, before stepping to the BTech, already you may be having a different ranks in the MSET or ESETs. But through the ranks, can you define the person intelligence here? May or may not, of course. But that is one of the factors to consider or to identify your intelligence. Yeah, your rank is also one of the factors to identify your intelligence or IQs. Through that, is it possible to define finally your most intelligent person, your best candidate like that? No, no, it's not possible. But based on some charge carriers. Charge carriers means, in general, human body is an electromagnetic cell. In general, in each and every classes, I used to say this. A human body is an electromagnetic cell means it consists of some charge carriers from a brain to the toes of your foot. In the sense, charge carriers are whenever it is flowing throughout your body, then only the body can consist of some power, some flow of charge carriers leads some current, that current leads some power. Okay, whether you can believe it or not, it's definitely happening in each and every human body. The same thing, whenever we are observing human body is an electromagnetic cell in one sense. In another sense, you can say human body is a good conductor. A good conductor means how we can define the conductor? Where there is a possibility to allow at any circumstances current to pass through it, that particular material we name it as conductor. Based on that opinion, we will consider it as human body is a good conductor. When we come to that conclusion, human body is a good conductor. Whenever we consider it's a good conductor, definitely some charge carriers are there. Yes, yes, some charge carriers are there. See, person to person, while observing a teacher, you may be having some different opinions on teacher and different graspings while receiving the things. Is it that based on what factors it's a different from person to person as a receivers? Based on your mentality, based on your observation, based on your peace of mind, you are concentrating on your teacher's lecture. That is, suppose if you are having more enthusiasm to listen the teacher, or if your body is present but mind is absent because you are moving somewhere else, definitely may not concentrate on your teacher's lecture. In that case, what to do? Means who are actually concentrating on teacher's lecture, they will be having more energy, they will be having more charge carriers in their brain. Okay, suppose come to the second category. A few members are in the dilemma whether to concentrate on teacher or observing something else, like that they are actually in the dilemma. Those are having a less number of charge carriers compared to the first category of people. Coming to the third category. Third category of people, body is present, totally mind is absent. If mind is absent means they are not making use of their charge carriers for listening the things whatever covered by the teacher. In that cases, definitely the receiving capability is changing from first category to second category to third category. Yes, definitely. So, teacher as a single source appears in your class, but different receivers are appearing like you people in the class based on your presence of mind, based on your mentality, or based on your status of mind, you are receiving the things. Is it? The same way, where as a teacher, we need more control on students means who are actually listening very carefully, We don't need to have any controlling over them because already they are listening. They are listening means we don't need to have any control just to take care of on that particular category of people. Okay, then third category. Let's just come to the third category. Even though if you put any effort, even though if you have pressurized them to listen, it's not possible in all the cases to concentrate or to pay their attention towards a lecture of the teacher because they are in the different trend and they are in the different mindset. Now come to the second category, which are in the bit in between of the first category to the second, third category. They are having some zeal to listen the things, but some disturbing characters are actually pulling them or changing their concentration. Because of that, they are not totally concentrating on teacher. In that particular cases, if the teacher plays a major role controlling of that category of people, definitely the second category will turn into the first category. Yes or no? Definitely. So that where there is a possibility to control better way in order to improve the quality or in order to improve the performance of a student, in what way the teacher can take the measures the same way, where there is a possibility to have better controlling, that particular material is only suitable for electronics. Okay, where there is a possibility to have better controlling, that materials are suitable for electronics. So now come to here, silicon and germanium, which material may be having more controlling, either on germanium materials or on silicon materials? Definitely on germanium materials we have less control because the number of charge carriers present in the germanium is larger compared to the silicon material. Silicon material having less number of charge carriers per cubic centimeters as compared to, or cubic unit you can say, as compared to the germanium material. That's the reason this germanium will consider it as the first category of people in your class and silicon will consider it as a second category of people. Okay, so insulators are as usual, of course, a third category of people. We won't bother about the third category of people. Whatever the measures we are taking in the class, they may not respond for that. So we can leave. We won't consider them into account as a students in the class. But these two categories of people, we have to take more care on this silicon material compared to the germanium material. Where there is a possibility to have better control, that material is silicon material. That's the reason we'll consider silicon material as a basic material for almost all electronic devices for manufacturing purpose also, either in the VLSI domain or in the electronics domain, totally for almost all electronic components, electronic devices manufacturing purpose, we can use the silicon material as compared to the germanium material. Okay, just a minute please. Okay, thank you. So that's the basic reason for using silicon and germanium materials. Now you know what's the reason for choosing silicon material for electronics as compared to the germanium material. Okay. Now coming to the what's the definition of PN junction diode? Just now we revealed that. That is two terminal semiconductor device is diode. Okay. So how the diode actually taking place? What are the characteristics of this diode? What are the applications of this diode? Let us see in today's class now. In this P N junction diode, just here I have mentioned P and N junction diode, and I have given some supply also. And that supply is also positive terminal is connected to the P type of semiconductor, and the negative terminal is connected to the N type of semiconductor. I think it's visible to all of you, P type and N type of semiconductors. This is P and N type of semiconductors. So whenever I have given this particular supply, and it allows the charge carrier's movement to take place like this, just. Okay. So charge carriers, because of this opposite polarity, holes are moving from P type to the N type, and electrons are moving from N type to the P type. Okay, electrons movement, in what way we have actually, electrons are moving here. That is, electrons are moving like this. The flow of charge carriers means the flow of electrons in general, we can define. The that particular current. But conventional current is opposite to the direction of charging carriers. The electrons are moving like this, but the conventional direction of current we can show opposite to the charge carriers, that is positive to the negative. That means always the current flows from higher potential to the lower potential. This positive terminal we consider as a higher potential, negative terminal as a lower potential. Always current flows from positive terminal to the negative terminal. That is always from higher potential to the lower potential. The current flows. Okay, but charge carriers are moving from n-type to the p-type. That is opposite to this direction of current flow. That's a conventional direction of current flow is opposite to the direction of charge carriers. That you have to keep in mind. It's very important note to remember. Okay, so now we know because of this, it's allowing more number of majority carriers can cross across the junction. Because of majority carriers can cross across the junction as compared to minority carriers, it allows a very large current to flow through the PN junction diode. In what way we have? Let us observe. It's a characteristics of PN junction diode. Now we have given positive supply, positive terminal to the p-type, negative terminal to the n-type. Because of that, what type of charge carriers are crossing across the junction? Majority charge carriers crossing across the junction. But until to get a sufficient voltage, the charge carriers doesn't move from its original place to the next place. Because of that means this particular supply voltage you have to increase from 0 to 15 volts. Let us consider the DC voltage of 0 to 15 volts we are giving. While increasing this 0 to 15 volts of a power supply, okay, until to get energize the charge carriers, it won't move from its initial position to the next phase because it has to energize first through this supply of an external voltage. Because of this external voltage, whenever the charge carriers gain its sufficient energy or sufficient energy, then only it starts to move from its initial phase to the next phase. At that time, here whenever it's a charge moving, then only we consider some current to pass through this particular junction. That current will call it as actually the diffusion current. I told you already. That diffusion current, it starts after certain particular voltage. That means initially the volt, suppose here you can see this is actually the voltage and current. Okay, this is a forward bias of course. Here voltage in volts, current in milliamps. These are the units of voltage and current. Okay, until to give some supply voltage, there is no chance to have any current in it. This is a current. This is current and this one is voltage. Okay, until to have certain supply, there is no chance to allow the charge carriers to move from one region to the another region. Because of that, here, until to have such a voltage, there is no chance to have any current, that is 0 only. So, after crossing this, then it starts to have some current flow through a junction that we are representing like this. Okay, this one is actually having like this. Okay, what it indicates after crossing this voltage, that means this particular voltage we will call it as V in or V cut-in. That is cut-in voltage of diode. Okay, cut-in voltage of diode. The meaning of this cut-in, C-U-T, cut-in voltage. We call it as cut-in voltage. Cut-in voltage of a diode. That means until to reach to that particular voltage, the charge carriers doesn't have any movement. After crossing that voltage, enough energy is gained. The charge carriers have its movement from p-type to the n-type. That is, after crossing this cut-in voltage, then charge carriers movement gets taking place. Then it allows some current flow through this junction. That is the current here. After crossing this cut-in voltage, the current starts to increase like this. This is the current and this one is the voltage. This particular characteristics we called it as actually the forward bias characteristics. Forward biased characteristics. Forward biased characteristics. Okay, because forward bias means p-type is connected to the positive polarity, n-type is connected to the negative polarity, and because of this particular supply, the depletion region is minimized. That means because of charge carriers, majority charge carriers are crossing across the junction, depletion region is reduced. Reduced means the thickness of the depletion region is minimized, then more number of charge carriers are crossing across the junction that leads to the larger current to flow through it. That's the reason we call it as forward biased characteristics. Forward biased characteristics. Now let us see here. This one is the forward biased characteristics of PN junction diode. And if you have applied the reverse voltage in the sense, this polarity if you have given negative polarity to this P type of semiconductor material and positive polarity to the N type of semiconductor material. Let us see P and N. This one is negative polarity given to the positive type P type of material and positive polarity is connected to the N type of material. Okay, if you have given like this, okay, this is P type and N type. Negative polarity. Here the majority carriers are holes. Already we know that majority carriers are holes. Because of this majority carriers are holes and this is actually a negative polarity and here the majority carriers are electrons. Polarity of these electrons are negative. Okay, so definitely opposite charges are gets attracted together. In that sense, holes are positive polarity charge carriers. Because of this negative, holes are gets attracted towards this particular negative polarity. And electrons of negative polarity charge carriers, this negative polarity charge carriers gets attracted by this positive polarity of the external voltage. Because of this, these holes are moving outwards towards, moving outward from this particular junction and electrons are also moving outward from this particular junction. So whenever these particular holes are diffusing towards negative polarity, electrons are diffusing towards positive polarity of the supply. Here the width of the depletion region is increased. Width of the depletion region increased in the sense like this. This is N type, this is P type. This is the width of depletion region increases. Width of depletion increases. Okay, increased because of attracting of these holes towards the negative polarity and attracting of this electrons towards the positive polarity, the depletion region width is increases here. Initially, the depletion region width is small because of a drifting of charge carriers. In this forward bias, that particular depletion region becomes very narrow. Okay, but whenever you have applied the reverse bias, this one is reverse bias. Whenever you can apply the reverse bias, so the depletion region width gets increases. Because of increasing of depletion region, is there any chance to cross the majority carriers across this junction? Definitely it gets minimized. That in the sense, how here holes are attracted by this positive negative polarity, electrons attracted by this positive polarity, here the depletion region increases means, but due to minority concentration of electrons from P region, holes from N region, there is a chance to have some amount of current to pass through the junction. Some amount of current to pass through the junction due to minority charge carriers only. Because of that minority charge carriers current, minority charges crosses across the junction. The current is very negligible current that will consider as very low current that in terms of microamps. The current here will get in terms of microamps and this one is a reverse bias voltage. A reverse bias voltage and this one is voltage forward bias voltage. And current in microamps in case of reverse bias and milliamps in case of forward bias. That is reverse bias, reverse bias characteristics if we observe. Reverse biased characteristics. Current in microamps, very less current it allows to flow whenever you are increasing the reverse bias voltage across this P and N junction diode. So these are the characteristics of forward biased junction diode and reverse biased junction diode. Totally characteristics of PN junction diode is this. So while doing the experiment, you are having this experiment as the first experiment after demonstrating equipment functionality in the EDC labs. You are having this experiment is the next second experiment, PN junction diode characteristics. There we can observe first this cutting voltage. After whenever the current starts to flow through the diode, that particular voltage will consider it as cut in voltage. That is, you are going to mark while doing the experiment from which voltage onwards a diode allows a current to pass through it. that current, that voltage will call it as cut-in voltage. That we have to mark in the tabular column. Voltage, bias voltage as well as current flow through the diode. Drop across the diode versus current flow through the diode. While explaining the particular characteristics, I'll draw the circuit diagram. In that circuit diagram also, just here, of course, this board again I have to draw. That circuit diagram can consist of a voltmeter, ammeters. Drop across the diode we are going to measure with the voltmeter, and current flowing through the diode we are observing with the ammeter. Always ammeters are connected in series with the devices, and voltmeters are connected in parallel with the devices. In such a way, we can complete the circuit diagram connections and observing voltage and currents by varying the bias voltages here, forward bias voltage as well as reverse bias voltage. We are going to perform this as one of the experiments in the electronic devices and circuits lab. PN junction diode characteristics or VI characteristics of diode. PN junction diode or VI characteristics of diode, both are same. Okay, so in today's class we have completed PN junction diode and its characteristics, how the charge carriers are allowed to pass through the junction, when there is a chance to have increase in the depletion region, when there is a chance to have decrease in the depletion region. So based on increasing the depletion region, it allows very less amount of current, that too due to minority charge carriers only. Because of decreasing of depletion region, it allows majority carriers to pass through it, that will call it as forward bias characteristics. It allows a required amount of current. So these are the characteristics of PN junction diode. It has its own applications in electronic devices and circuits. That applications we call it as actually the first application of diode is a rectifier. Diode acts as a rectifier. Might be you have come across this concept also in your inter applications of the diode. Applications of the diode is the first application we consider it as rectifier only. After this rectifier, you have clampers, clippers. These are also given in your syllabus as a clampers and clippers in the first unit itself. So let us see in this particular class, in the first unit, what are the topics we are having and how we are going to concentrate on these particular topics. Like in each and every subject, we will be having some objectives before starting the subject. Like before doing the experiment, every one of us first we have to define what's the aim of the experiment. Similarly, before entering into the actual subject, we have to define what are the main objectives of this subject. Subject in the sense, in general notation, we call it as a subject, or otherwise we'll call this one as a course. That's the reason course objectives. After completion of this course objectives, what are the outcomes? Outcomes means what a student can able to perform, what a student can learn soon after completion of these concepts. We'll define it as outcomes of the subject or outcomes of the course. Those will name it as course outcomes. Like while each and every experiment, first you should know what's the aim of the experiment. After knowing the aim of the experiment, what's the procedure? What are the equipments we are using for performing of that particular experiment? Or in order to get results, what are the equipment it needs or what are the components it needs? Like this, first you have to think of it. The basic materials. After that, what's the procedure? With what procedure we can extract the required information in order to justify our objective. That's the procedure. After completion of the procedure, then we'll extract some results. Before performing an experiment itself, we should know what type of results we are expecting. Then only we come to know that the results are actually optimum or the required results only we are getting or any wrong results we are getting. In such a way, we should define some statement or we can define whether the results are correct or not. After completion of the results, then you come to know some conclusions. Conclusions of that particular experiment. Similarly, here, each and every course also will have some conclusions or some that we will call it as outcomes of the subject. So first, what are the objectives of this main electronic devices and circuits in the sense? In this we have main introduction of components like almost all we have come across semiconductor basic materials. Okay, components in the sense basic components or resistors, capacitors, inductors that I have given already in the last class. Of course, I'll continue that in the next video also. Resistors, capacitors, inductors. Briefly, I would like to give here the information regarding this particular basic components. All are in this particular electronic devices and circuits. We are using two-terminal semiconductor and two-terminal components like resistors, capacitors, as well as inductors. What's meant by the resistor? What's meant by the capacitor? What's meant by inductor? There is no any ideal resistor, ideal capacitor, ideal inductors appears at any cost in anywhere else. Each resistor have its own capacitance as well as inductance. Similarly, each capacitor also have its own resistance and inductance. Each inductor also have its own resistance and capacitance. But what's the basic difference between these main three components? Resistor which opposes the flow of current in general we can define it as a resistance based on that which resists the flow of current, which resists the flow of charge carriers. That is the basic nature of a resistor. And a capacitor having the different property. It can stores the energy in terms of electrostatic field, and it can delivers that energy whenever it requires. That is, charging and discharging capability a capacitor should have in terms of electrostatic. Then come to the inductor. It's also having the charging and discharging capability in terms of electromagnetic. Okay, energy stored in terms of electromagnetic and delivers whenever it requires. These are the basic differences between resistor, capacitor, inductor. These are the basic components in general for any of the electronic equipments we are making use of it. Let us say, I would like to give some best example in order to understand the basic properties of the components by keeping you as a students in mind. I am giving this example. In what way means, let us imagine myself as a teacher, which will consider as an active source in the class. Because I am delivering, you are receiving. That's why I'll consider it as an active source in the class. And you people are three different types of components. Three different types of components in the sense, a few are acting as resistors, and few are acting as capacitors, few are acting as inductors. In the sense, few or resistors in the sense they haven't they are not concentrating better on lecture. They are always opposed to listen. Those characters will name it as resistors. And some G characters are there in the class. Those are very interestingly listening the things, and they have that much of reproducing capability also. They can reproduce whatever they are learning either in the bypass or either in the exams. But the presentation skills may be different from person to the person. Based on that, you can categorize. Few characters are capacitors and few characters are inductors. Like this, I feel all are my students are different types of components to me. Myself is an actually active source in your class. Whenever I am delivering a speech as a power, if I am supplying power, each one of you are receiving those in different way. You are getting knowledge through this particular lecture. That knowledge you are storing in your brain based on your storing capability or storing, and whenever there is a chance to reproduce, you are reproducing that. Okay, so I feel this is actually either circuit or a network. Better to consider network. Circuit, no need to have any active source. So I'll consider the total my class is a network. A network can consist of one active source like me and a different components like you people having in that particular network. Okay, so each component is very essential presence in very essential to have in the network or in the circuit in such a way. In each and every class, all categories of people present in the class. There is no class only meritorious students. There is no class only dullers. Definitely, it's a combination of the students only appears in the class. But how we are actually concentrating on our lecture, how we are, what purpose we are coming to the class, what we are listening, what is our goal, what's our aim, what purpose we are studying this particular subject. If you think of this, then automatically you get concentration and you can listen the things. Without teacher also you can learn the things. That's it. Okay, so that is an impact of the teacher, and that is an interest of a student to sit in the class and listen the things covered by the teacher. Okay, so in such a way, three components basically we have: resistors, capacitors, inductors. With these three components, we are going to have with the active sources the total circuits as well as networks. Okay, that is the first objective. Introducing of components as well as diodes, BZTs, effects like this. Like diode already we have completed. It's a two-terminal semiconductor device as a diode. Three-terminal semiconductor device is BZT, bipolar junction transistor. Similarly, we have three-terminal semiconductor device like a field effect transistor. Based on its nature of working, nature of its performance, nature of its characteristics, we have given these two different names like bipolar junction transistor and field effect transistor. Both these transistors having three terminals, but the working principle is different for bipolar junction transistor as well as for field effect transistor. We'll come to know that in the second units, that BZT effects. Then second objective of our electronic devices and circuits is an applications of these components. Like once you have completed the basic diode and its applications, BZTs its applications, FETs its applications. Okay, third one is know the switching characteristics of components. In what way switching action gets performed, all of these components. That switching characteristics of components also will come to know that in this particular subject of EDC. Then understanding of various types of amplifier circuits. So as a basic electronic students, we need amplifying skills. Amplifying skills in the sense, each one of us having some amplification capability, and each one of us having some attenuation capability also. Amplification means once you have listened something, and if you have added something to it, or if you have given that information very loudly to some other person or to some other end, that particular way of performing the task, we call it as an amplifier. Amplifying means increasing the strength of the signal which you have received, and at its output, if you have sent that particular increased strength of the signal, then you will be called as amplifier. So each one of you have such a capability as a students, amplifying the things. See, whenever you have less marks, you can amplify the voice like, my teacher is not good, that's the reason we have less marks. Okay, is it? Attenuation in the sense, suppose teacher has given some homework and informing through WhatsApp groups. You have to complete this particular so and so task and so and so time. So, but you are not hiding that particular. Sorry, you are not explaining these things. You are totally hiding those. That in the sense you are attenuating. That means you are not showing these things to your parents. And whenever results coming, then you can highlight teacher is not good and teacher is not covered that particular topics, and that's the reason we are not performed well in the exams. Okay, these are some examples of amplifying the things and attenuating the things. Okay, then coming to the actually oscillators, like these are also we are having in the upcoming semester. Electronic circuit analysis. Electronic circuit analysis prerequisite is EDC. EDC, electronic devices and circuits, doesn't consist of any prerequisites, because prerequisites are nothing but physics. We have completed some basic information of p junction diodes, as well as basic semiconductor materials, basic material concepts. Those are all prerequisites of electronic devices and circuits. You know what's meant by the prerequisites, which are very essential to learn the upcoming semester. That particular concepts we call it as prerequisites for understanding of that particular subject. Okay, those are the prerequisites. Similarly, for electronic circuit analysis, EDC is the prerequisite. There we have oscillators. That is, oscillator and amplifier. These are the main applications of a three-terminal semiconductor device, that is BZT. Amplifier, which strengthens the signal. Oscillator, it actually generates the signal without having the basic AC as an input to that particular uh, device. That in the sense, without having any AC, without having any AC, if it generates the AC, that would call it as an actually oscillator. That means, or in another terms, we'll call it as DC is converted into AC is also an oscillator. Or without having any AC, if it generates the AC, that would call it as an oscillator. Like this, we have amplifier and oscillator as the basic applications of bipolar junction transistors. These are the main objectives of electronic devices and circuits. And what are the main outcomes of this particular subject in the sense? We have some outcomes also, that is, in order to understand these particular components, first you should go for characteristics like this. So, know the characteristics of various components. Each and every characteristic for each and every component you can see in this particular subject of EDC, that is outcomes. Then second one is understand the utilization of components. That means understand the utilization of components means basic applications, where we are using, how we are making use of it, and what conditions we can make use of it. What are the changes of this particular components on different circumstances that we can see. That you are in a position to get the knowledge through this particular subject of EDC. Then understand the biasing techniques. Okay, what's the need for biasing? What are the different types of biasing techniques we are having? And without biasing, what happens? With biasing, what happens? That we come to know that after completion of these biasing techniques. That's the main, you are in a position to understand after completion of this subject the need for biasing. That we named it as an outcome for this particular subject. Design and analyze the small signal amplifier circuits. Based on the different frequencies, and here we may be having different types of amplifiers. So that's the reason you are in a position to categorize the different types of amplifiers with the different components of an electronics after completion of this particular subject. These are the basic outcomes of this electronic devices and circuits. At last, we are having some field effect transistors and field effect transistor characteristics. Out of these field effect transistors, based on its terminals, different characteristics are there, and different applications we can make use of it, field effect transistor. And while entering into this particular subject, we come to know that for each and every component, the reason for calling with that particular name of bipolar junction transistor, field effect transistor, these are all the things we come to know that in the next videos. Okay. I hope you are in a position to understand in today's topic the basic reason for entering into the semiconductor materials. Out of this semiconductor, the silicon material why we are entering and why you are using in electronics. Out of this semiconductor, silicon why you are entering. Then after completion of this particular discussion, what is an actually a PN junction diode, and what's meant by the forward bias diode and reverse bias diode, and what are the characteristics of PN junction diode, and how we are plotting the PN junction diode characteristics, and this particular brief introduction regarding the basic objectives of this course as well as outcomes of this course we completed in today's class, and we'll continue the next in the next class with the other components and its characteristics. Thank you.